So now we're going to apply the prisoner's dilemma to oligopoly. We have two firms here, and basically we're deciding whether to collude or not. So the collusion outcome would be to each decide to produce 10 units. I just made up numbers here. Or you can kind of cheat on that collusion agreement and go ahead and produce 20. And we're just going to go ahead and go through this game like we would any game, and see what the outcomes are going to be. So first, you just want to go through your strategies, check for dominant strategies, and just read the table the same way every time. So we're going to start with player one. Doesn't matter who you start with, and then remember we're going to look at what are the two possibilities of what the other player is going to do, and just run through the payoffs. So for firm one, either firm two is going to produce 10, and we're looking at this column, so we're comparing these two payoffs. It's better for firm 1 to produce 20 if firm 2 produces 10, and if firm 2 produces 20, we're looking at these two, and it's better for firm 1 to produce 20. So firm 1 has a dominant strategy of producing 20, and the other player, so now we're looking at firm 2's payoffs, so we're looking at what are the two options of what the other guy is going to do. Now we're going this way. So firm 1 produces 10, better for firm 2 to produce 20. Firm 1 produces 20, it's better for firm 2 to produce 20. So we get dominant strategy of producing 20 for firm 2. This was symmetrical, and we get this Nash equilibrium over here of producing 20. So this is a prisoner's dilemma. The structure of these payoffs make it a prisoner's dilemma. So we have this cooperative outcome from the perspective of the firms, an incentive to cheat on the cooperative outcome because of the other person's cooperating. I can do better, let him be the one to hold down production and agree to produce less. I'm going to go ahead and produce more, take advantage of the fact you're helping to keep that price high. I'm going to go ahead and cheat on that agreement. So this is similar thing happens with OPEC when they decide on oil production. It's to the best interest of the group to keep oil production low, but there's always an incentive to cheat on that agreement. So collusion easily breaks down because there's going to be that incentive to cheat. You go ahead and keep production low, that's going to benefit me if I produce more. So I'm kind of taking advantage of that fact. So there's this incentive to cheat. Both firms have an incentive to cheat. And then the dilemma from the point of view of the firms is we end up in this worse outcome, assuming we both play those strategies, this Nash equilibrium, which if we were just somehow able to cooperate, then we could have been here. Now we end up here. So our collusion has broken down if this is our game and if rational players play their dominant strategies. So from the perspective of consumers, it's a good thing that collusion breaks down like this because it's better for consumers, obviously, if firms are producing more and driving that price down, and so it's essentially a more competitive market. So just to relate this to a graph, which we usually won't really need too much, but so this is just a simplified monopoly, and so the collusion outcome, both firms are colluding. We're basically looking at the industry output, trying to maximize industry output as a whole, and then splitting those profits. So that's the collusion outcome. And so the collusion is basically let's act like one big monopoly, because if we were just one firm, the best we could do is act like a pure profit maximizing monopoly that would maximize total industry profit, and let's just split those profits. So that's what we're calling this collusion outcome. It's the outcome in which we act like one big monopoly. Let's pretend we're going to join firms and be one big monopoly. So that would be the best the industry as a whole could do would act like if this was one big monopoly, produce here, charge this price, get those profits, split those profits. So that's kind of what this collusion outcome is. Now keep in mind, once you leave the monopoly outcome, so if we stopped acting like one big monopoly, this marginal revenue curve no longer applies. Right? This is the curve for the entire industry. So, or if you were one firm being a monopoly. So remember, what's going on is, should I produce one more unit? Well, if I'm a single price monopolist, which is what we're assuming here, this single price output, to sell that next unit, I have to drop the price on all my units, which puts my marginal revenue curve down here. That's only if I'm the entire industry or one firm being the entire industry in the case of a pure monopoly. So in the collusion outcome, that's what we're sort of acting as. one big firm. But once we go independently, then we're no longer have this monopoly marginal revenue curve. So this actually starts to move up, because what's going on is if I'm an individual firm that's not the whole industry, I still have a price effect. So remember, monopoly had that price effect for the entire industry. But if I'm one firm in, this is a duopoly case with two firms, or one firm in an oligopoly with few firms, not many, but few enough so that we have a significant effect on the market. So I would still have a price effect if I'm one firm in an oligopoly, but the price effect is smaller than it would be if I was a monopoly. So that's why this margin revenue curve would not apply to each individual firm, because each individual firm only cares about its own price effect, right? So if I sell the next unit, this is still showing me the industry demand curve, right? The demand curve facing this industry. So I'm going to sell that next unit, the price has to drop, but I only care about how the price affects my own output. So I'm going to have my own price effect, which is smaller than what that monopoly price effect would be. And because of that, I have more of an incentive to produce than a monopoly would, right? Monopoly doesn't want to go past this point. But if I'm a firm in an oligopoly, I do have the incentive to go past that point, because this is not actually showing me my individual price effect. My marginal revenue curve would start to become closer to that demand curve because the price effect would be smaller. So that's why each individual firm has an incentive to produce more. And when we both follow that incentive, we end up producing even more than that, which again ends up in this prisoner's dilemma type situation. So an oligopoly, if collusion breaks down, now the thing about oligopoly is we can't really strictly predict what's going to happen, because it is possible to get collusion. Although if we simplify it and turn it into this one-shot game, and we assume rational players play dominant strategies, then collusion breaks down. But it is possible, obviously, sometimes happens that you do get collusion. So maybe there are other factors that are not really reflected in this. For one being that we might play a repeated game, in which case that kind of changes things. So the oligopoly case, in the case that collusion breaks down, we end up somewhere greater than monopoly output for the industry, which is what we have here. So the monopoly output would be 10 and 10, total of 20. If we get cheating over here, this guy's going to produce 20 while he's producing 10. If we both, cheat and produce 20, we're going to end up producing 40. Now remember, there's still a price effect going on. It's just not as large as monopoly would be. So what might happen is that we produce more than a monopoly would, but less than a perfectly competitive market would. So remember, perfectly competitive industry, if say we had 1,000 firms doing this, right, we would probably just go out to here where price equals marginal cost. Remember, there's no price effect when you have perfect competition. Here we have some price effect if we have a few firms producing, as opposed to that monopoly price effect, which is reflected in this marginal revenue curve. So what we might predict in this kind of simple scenario is that we get somewhere in between that monopoly outcome, the collusion outcome of two firms acting like a monopoly, but not quite all the way to perfect competition. So there's different oligopoly models that we're not going to get into, in which you could have, we can get that collusion, and we could even get the something that looks like perfect competition if we get into a price war. It is possible that we can go all the way out there. Although in this kind of situation that I've created, we're sort of somewhere in between the two. And so I'm just assuming there's kind of this one other outcome, this one other strategy of producing 20, and I'm going to call that, somewhere in between those two outcomes, because I still want to have that price effect, just not as large as it would be if we were a monopoly. So this is one example of prisoner's dilemma. So just the structure of these payoffs makes it a prisoner's dilemma.